Okay, so we've all heard it a million times. Chronic inflammation is bad news. It's tied to all sorts of diseases. But what if it's doing something even more fundamental? What if it's one of the key things actually driving the aging process itself? Well, today we're putting on our detective hats and diving deep into a cellular level whodunit, connecting that slow burn of inflammation to the ticking of our own biological clocks. Right. So here is the central mystery we're trying to crack. When it comes to aging, is inflammation just a symptom? Our body's getting older, breaking down a bit, and naturally sending out these alarm signals? Or is inflammation the actual arsonist here, the one actively fanning the flames and making us age faster? It's a real chicken and egg problem, and we're going to get to the bottom of it. To figure this out, we have to start by investigating our prime suspect, the normal, natural process of aging. And to do that, we need to talk about these tiny, ticking clocks that are inside every single one of our cells. And here they are. Meet the telomere. The best way to think about these is to picture the little plastic tips on the end of your shoelaces, right? Just like those aglets stop your laces from fraying and falling apart. Telomeres protect all the super important genetic info inside our chromosomes. They stop it from unraveling every time a cell divides. They are, and this is no exaggeration, the molecular clocks of ourselves. The thing is, this clock is always winding down. Every single time a cell divides, a tiny little piece of that telomere gets snipped off. It just gets shorter and shorter and a little bit shorter until finally it hits a critical point. And when that happens, the cell gets a very clear message: time to retire. Now, this retirement state has a fancy scientific name: cellular senescence. It's basically when a cell permanently stops dividing, and it's actually a good thing. It's a crucial defense mechanism that stops cells from growing out of control, which can lead to things like cancer. So the clock runs out, the cell stops dividing, and that's the end of the story, right? Well, not quite. And here's the twist in our story. These retired cells, these senescent cells, they don't just fade away quietly. Oh no, they are very much alive, and frankly, they get a little grumpy. Instead of dividing, they start spewing out this nasty cocktail of inflammatory signals, molecules you may have heard of like TNF-alpha and IL-6. They become these cranky old cells just shouting inflammatory complaints to all their neighbors. This whole grumpy cell phenomenon is called the senescence-associated secretory phenotype, or SAS for short. And this is the key. This is how our aging cells literally become tiny, nonstop inflammation factories. They just pump out these signals, creating this constant low-grade inflammatory fog in our bodies. So, there we have it. We've solved the first half of our mystery. Aging absolutely causes inflammation. Case closed? Not so fast. Because that is only half the story. We've just seen how aging can kickstart inflammation. But now we have to flip the script and ask, what is all that inflammation doing back to our bodies? So we've got a really clear connection here, right? Aging leads to inflammation. But what if it's not a one-way street? What if all that inflammation can turn around and actually speed up the aging process itself? What if this is a feedback loop? Okay, to get this, we have to introduce our next key player, reactive oxygen species, or ROS. Just think of inflammation as a crackling fire. ROS are the tiny, destructive sparks that fly off of it. They're these super unstable molecules that just ricochet around inside our cells, damaging pretty much anything they bump into. You might have heard this called oxidative stress, or a simpler way to think of it is just cellular rust. And which part of the cell is especially vulnerable to all these damaging sparks? You guessed it, our telomeres. A huge study in Nature Communications really nailed this down. The sparks from the fire of inflammation, the ROS, they go and directly attack the telomeres. This makes them shorten even faster, which forces even more cells into that grumpy, inflammatory senescent state. So we circle back to our big question, the final verdict in our cellular whodunit. Who's the real culprit here? Was it the aging cell that started it all, or was it the inflammation? And the answer is, it was both of them. They were working together. It's not a simple cause and effect. It is a devastating, vicious cycle. Let's walk through it. Aging creates senescent cells. Those cells churn out inflammation. That inflammation creates cell-damaging ROS. The ROS then damages more telomeres, which forces more cells into senescence, which then creates even more inflammation. You see? Each process fuels the other, creating this downward spiral that actually accelerates the aging process. Now, this isn't just some interesting science happening in a lab somewhere. This cellular cycle has massive, real-world consequences for our actual health. This cycle, this whole process of telomere damage, senescence, and inflammation, it has a name now. Scientists call it inflammaging, and it's now seen as a major contributor to a huge list of age-related diseases. This exact feedback loop is a key driver behind things like cardiovascular disease, diabetes, arthritis, and even neurodegenerative disorders like Alzheimer's. Now, here's the most important takeaway from all this. This is not some process that's just set in stone. We actually have some influence here. Research is making it crystal clear that our lifestyle choices can either pour gasoline on this inflammatory fire or help put it out. Things like smoking, a poor diet, and chronic stress, they speed up the cycle. But a healthy diet, good sleep, and managing stress can help slow it way down. So if this really is a cycle, that leads to the biggest question of all, doesn't it? Can we break it? Can we actually intervene here and slow this whole process down? Well, the research is pointing to a pretty hopeful yes. For instance, in that same study, scientists looked at mice that were basically designed to have chronic inflammation. And no surprise, they aged way faster and their bodies couldn't heal or regenerate tissues properly. But, and this is the cool part, when they gave those same mice an anti-inflammatory treatment, it was like a switch flipped. It completely stopped those grumpy senescent cells from piling up, and it restored their body's ability to heal. Just like that, the cycle was broken. So we started with a pretty simple mystery and ended up uncovering this complex, self-fueling cycle that sits at the very heart of how we age. And that leaves us with a really powerful final thought. If we can learn how to break this cycle of inflammation, are we on the verge of being able to truly change the pace at which we ourselves age?